The water consumption of each family follow a normal distribution with mu meters cube and the standard deviation of 4 meter cube. If you let the water consumption of each family be x, the random variable, then is follow a normal distribution mu and 4 power of 2. Now we are going to carry out a survey to estimate the mu here. We take the random sample of 16 families, so we are not considering x, but here we are considering the sample mean. X bar also form a normal distribution with the mean, which is exactly the same as the original data mean, but the variance will be divided by the number of data we draw. Now we draw 16, so we divide by 16. Therefore, the sample mean x bar follow a normal distribution with the same mean, but the standard deviation is much smaller, which is 1 only. When we construct the confidence interval for mu, we need the starting point, and then we use the data, the sample mean, to be our starting point. We just add all the data together and then divided by the number of data, 16. We get the sample mean is 20.75. After that, we are going to construct our interval estimation. Because 1 point is not accurate enough, that's why we need our confidence interval, 95%. Our starting point is 20.75 minus something and 20.75 plus something. The width depends on the accuracy here. The accuracy, they say 95%. If we have a data by the standard normal distribution table, to include 95% in the middle part, that means each part here, we need to include 0.475. And then we have to check the table to search for this area 0.475 and see what is the corresponding standard score here. For this area, the corresponding standard score is 1.96. That means if the standard score is between negative 1.96 to positive 1.96, then we include 95% of the data. So we minus 1.96 times of SD. SD here is 1 that we already calculate. 1.96 times. But we didn't show the steps, so we better write down 4 divided by square root 16. That's how we get the standard deviation here. So it's equal to 18.79 and 22.71. That means this interval have a 95% chance to include the true mean. And part B, we just focus on the width, that means plus something minus something here. 2 times of the corresponding standard score of that requirement times the corresponding deviation. And the width here need to be smaller than 3. Just now, when the sample size is 16, then the standard deviation of the sample mean is 1. Now it's different because we are talking about another number. I don't know what is that number, but it's the answer that we need to find, the least sample size. So we just let it be n. When the sample size equal to n, then the sample mean, that means x bar here, will follow a normal distribution with the same mean, but the variance will be 4 squared divided by n, which means that now the standard deviation for the sample mean is equal to 4 divided by square root n. So we put 4 divided by square root n here this time. Just now it's divided by square root 16. Now it is divided by square root n. And then we still need to work on the corresponding standard score here. Is based on the required accuracy here. When the accuracy is 95%, then the standard score is 1.96. So now we use similar logic. We need to find the boundary to include 99.5% data, which means that in each half, we need to include 0.4975 of the area. Then we search the table. We search among the area to have 0.475. We find that 0.475 is here, which means that the corresponding standard score is 2.81. So now we know that C here is 2.81. Then we have an inequality with n only, so it's easy to find it out. And then both sides times square root n. Since square root n must be positive, so it won't cause any effect in the symbol there. Square root n is larger than 7.49333 something. So we can take square on both sides without changing the direction, because I know n is positive. N is larger than 56.15. Which means that the least value, that means least integer, is 57.